No. All right. 3.3 uses properties of logs, and I'm going to give you another sheet on that here shortly also. As you can see, the very first thing here is your change of base formula. Haven't we already talked about that? And actually, if you get your calculator out, I'm going to show you something. We're just going to explore a little something here. So remember, there's two different ways that you could, depending on what kind of calculator you have. This, if you don't have the change of base program underneath the math menu in your calculator, so if this were my calculator, which it sort of is, I'd hit the math menu and look on this. This is the old calculator. If I go down the math menu, I don't have any alphanumeric commands, do I? All right, so that's how you know if you have an old calculator versus a new one. So on my calculator, I don't have that change of base. So if you don't, you're going to do it this way. The log of this top number divided by the log of the base. And the same goes for the natural log. So if you have a natural log that's not a base of e, that's usually your common base, but if it doesn't, then you take the natural log of this number divided by the natural log of whatever the base is. So let's look at these. This is supposed to read a natural log down here. Right? Yeah, they look exactly the same, but this is log and this is natural log. So we're going to explore it here for a minute. So let's find this one. This would be log of what? 30 divided by log of 4. So this is assuming that you have log base 10 of 30 divided by log base 10 of 4. And so if I put that into my handy dandy calculator, log of 30, get in the habit of closing your parentheses, divided by log of 4. What'd you get? And round to, let's round to 3 decimal places. 2.453, right? Approximately. 2.453. So let's do the same thing with the natural log. So I've got the natural log of 30 divided by the natural log of 4. Oh, interesting. Remember what the graphs look like? They were identical, right? So this is natural log of 30 divided by natural log of 4, and that also is approximately 2.453. So in your notes, you might want to note in here, same. Isn't that fascinating? Oh, I just love math. Just you're pondering it. All right, so that's something that you should be familiar with, right? Okay, so then properties of logs. Okay, one more click. I'm trying to get it clear. Ha. All right, so properties of logs, if you look at these, they should be familiar as far as, hopefully you had them last year. If not, they're very similar to exponent rules. So if I were you right here, I would put very similar to exponent rules. And here's what I mean by that. Are you ready? Can I move it? All right, so if you look at number 1, if you have a log base whatever of something times something, u times v, when you multiply like bases, what do you do with the exponents? So here we are adding the two logs together. So we split it. It was called expanding. To go from here to here is expanding. To go from here to here is compressing. You're making it smaller. So if I've got the log of something that's being multiplied together, split it apart and take the log of each one of them separately and add them together. Same thing occurs with natural log. So the rule is not any different. Look at division. If you divide like bases, what do we do with the exponents? We subtracted. So you're not learning anything new that you haven't learned before. So if you can apply your exponent rules to here, they're very, very similar. Same thing occurs with natural log. So we have that very same thing. And then this is interesting. If I had the log base something of something raised to an exponent, this exponent right here is going to get swung out in front and be multiplied to that log. So whatever that exponent is, swing it out in front and multiply it to the log, and then we just have that exponent times log base a of u. Again, same thing occurs with natural log. What's the understood base here? E. And so this really is considered the exponent, and it gets swung out in front and gets multiplied to that natural log of now u. So we're going to apply some of these down below. So notice that example 3 says to expand. Know the difference between whether we're expanding or compressing? So I have 5 times x cubed times y. What's the first thing that's happening? How can I expand that out? Split it apart into log of 5. I don't have to write the base 10. It's understood as base 10. Plus, because I'm multiplying, log of x cubed plus log of y. Is there anything else that I can do to it? Yeah, you can take this exponent of 3 and swing it out in front, and you do need to do that. So we end up with log of 5 plus 3 log of x plus log of y. That's your final answer. And this is going to become very, very handy when solving logarithmic equations. Yay. Now, if you want to go from here to here and not show this interim step, that's fine. Some of you are already naturally there, and you can do that. There are some problems that you're going to get to. Well, that's a little harder to do. All right, so look at this one. We're dividing, right? Mm-hmm. Technically, this shouldn't be here. This isn't meant to be there. That should be gone. So, if we're dividing, what do we do? We subtract. So we start out with the natural log of the square root of 3x minus 5 minus the natural log of 7. Whatever goes up top always comes in front of the minus sign. Can I do anything with this? Can you write this in exponential form? You learned that in Algebra 3-4. How does it look exponentially? What's a square root exponentially? Yep, as a fraction, 1/2, right? Wouldn't a cube root be 1/3? A fourth root would be 1/4. So the denominator, if your exponent is a fraction, the denominator is your root. What does the numerator stand for? Yeah, what if this were 3x minus 5 in parentheses raised to the 3rd power? If this underneath here, the whole thing were in parentheses and raised to the 3rd power, wouldn't you then have this 3x minus 5 raised to the 3/2? 3 for the power that it is, and 2 for the root. So let's look at it. So this is actually natural log of 3x minus 5. It's raised to the 1/2 minus the natural log of 7. Then this exponent gets swung out in front, and you end up with 1/2 times the natural log of 3x minus 5, and that 3x minus 5 does have to be in parentheses, minus the natural log of 7. So when you do your homework tonight, you might have some where you end up with a number up here. And that number would represent whatever this is down here. You know, let's say that I had this here raised to a 3. Then that becomes a 3. Or if this here is raised to a 5, then this becomes a 5. All right, look at example 4. Now we're condensing, which is what I call compressing. You're pushing it back in and making it just one log. So you might want to write yourself a note here, make into one log or a natural log. So take each piece one at a time. If you have something that's in front, right, like I have this 1/2 that's in front of the log of x, can't I unswing it back up here to an exponent? So do it in pieces. I have log of x raised to the 1/2 plus, and then this 3 right here gets swung back up to here, plus log, and in parentheses, x plus 1 raised to the 3. So then we have to take this out of exponential form if we can, which we can. What does x to the 1/2 really mean? Square root of x. So this is log the square root of x plus log x plus 1 to the 3rd power. We really wouldn't change. So then I have 2 logs being added. What do you do with addition to go in reverse? Multiply. So our final answer is log of square root of x times x plus 1 to the 3rd power. So there's your final answer. Remember, your notes are always should show more work than you would in your own homework, because you're going to forget once you leave here. So don't skip stuff in your notes. All right, then look at this one. Try that one on your own. Only it's natural log, but that shouldn't bother you. Share your answer with those around you. See if they get the same thing as you. Did you talk to anybody? I didn't hear you talking. Talk, talk, talk. What's the matter, Miss Abby? Oh, I said you're not going to college? No. Yes, you are. Yes, you are. You're wonderful pre-calc kids.
And then you said, and they're like, okay, so this is how you like look for colleges, and this will find like scholarships and stuff. And then you find out that you're not going to college. Yeah. Your weighted GPA, the colleges don't see that. They see your unweighted GPA.
Yes, this is true.
It's all really, really sad. Yeah.
Okay, let me just tell you that these state universities take anybody.
I know.
That's, yes, it is. ASU is better than U of A. Go Sun Devils. Woohoo.
Sun Devils lost this weekend.
Okay, okay, don't even start with me because I really did have a bad sports
I think
week.
NAU is the best.
The Sun Devils lost in the last 2 seconds. The Cowboys lost to horrible horrors, the Giants, by 2 fingers. And then what else happened? Oh, the Detroit Tigers didn't even win a game. All right, back to pre-calculus. Because they've got a cute mascot, the Detroit Tigers. All right, here's the answer to the second part of number 4. Did you catch on to the fact that because it's subtraction, we're dividing it, should look like a fraction? So that's the only difference between the first one over here and this one is we had subtraction. All right, so then it starts to get even more, I don't want to say tricky because it's not really tricky, but it's, using your smarts. So right here, I mean, we could do 75 divided by 3, right? Because we have the same log, same base, right? And they should be the same base. If they're not the same base, we're in trouble. So because they're subtraction, can't I write it as log base 5 of 75 divided by 3? These are your notes. This is why you're writing this down, because you'll go, how the heck did they get 25, right? So then from there we get log base 5 of 25. So no, you'd leave it there, right? Not true. We actually have a value for that. Why? Why is it 2? Can you change this into exponential form so it actually has an exponent? This is not an exponent. 25 is not an exponent. It is the log, right? This is the base of the log, and this is what we're taking the log of, right? It's not an exponent. So what is 25 as an exponent? And notice that our base is 5 for a reason. Log base 5 of 5 squared. And remember one of the properties we had before? If those are the same, what does it equal? That's how Mike came up with 2. So your actual answer to this, because we're using the properties to solve now, is it has a value of 2. Because if your base and what you're taking the log of are the same, don't they cancel each other out, we found out, and whatever that exponent is, that's the value. And if you took your handy dandy calculator, can I borrow somebody's? Thank you very much. And let's just plug this into our calculator. So I'll put this over to the side. And so if I have, I have to do a change of base formula, don't I? So let's just do it. So log 75 divided by log of 5 equals, right? 6.2, whatever, minus, I'm going to put this in parentheses, log of 3 divided by log of 5. And I'm going to use double parentheses to close out the original parentheses, equals, what was that answer right there? 2. It was actually what? Wasn't it? Super exciting. I love this section. So much fun. It's like a puzzle. All right, so then here, what are you not seeing on these natural logs?
The E.
The E here and the E there. Here an E, there an E, everywhere an E. Now we're getting punchy. All right, so these E's and these E's actually disappear, don't they? Well, it really doesn't matter how you do it. This has a value of 3, and that has a value of 7, right? What do you think the answer is going to be? Interesting. Well, it looks like it should be -4, right? Okay. How else could you do it since they're being subtracted? Well, it's not dividing yet because there's what? What'd you just say, Paris? What'd you just say? They actually have exponents, right? So you could either, so there's 2 different ways you could approach this. Because remember, unlike the other one, you're missing the natural base down here, right? So it's harder to see that the 3 and the 7 are actually exponents, aren't they? Once I put it in there, then you can see it. So technically you could swing that exponent out into the front, couldn't you? So you can have 3 natural log of e to the e minus 7 natural log of e to the e. And we know that natural log of e to the e has a value of what? 1. 3 times 1 minus 7 times 1 is 3 minus 7, which is indeed -4, right? So that is one way. But then we could have said, okay, wait a minute, right here, just right from here. This has a value of 3, and this has a value of 7, so that equals -4. Either way that you go about it, so I'm going to put a big or here. Either way that you go about it, you still got the same answer. Right? This is a more complicated way, but if you can see it as this way, that's the way that you really should go. Even though we had subtraction, we wouldn't be dividing here because we can convert that natural log of base e to the e to an actual value. Any questions on that? Excellent.